All right, the first thing we're going to learn about in this in-between chapter is about absolute value equations. So by the end of this lesson, you should be able to solve equations containing an absolute value. So this is a little different than what we did in class today, because what we did in class today was just evaluating or simplifying. And what we did in class is I gave you problems like this, and you had to just simplify this to this, and then find the distance that -8 is away from the number line. What you are doing here is not solving. We didn't get x equals something, and that's what we're going to get now that we are doing solving. So you'll get an equation like this. The absolute value of x, something we don't know, equals 3. So remember that absolute value is its distance away from 0 on a number line. And since absolute value represents distance, it can never be negative. So when I give you this problem right here, the question you should be asking yourself when you see this, the absolute value of x, you should be saying, what numbers are 3 spaces from 0 on the number line? So stop and rack your brain, but the two numbers you should come up with are 3 and -3. Those two numbers are both 3 units away from 0 on the number line. So the two solutions of this equation are both 3 and -3. We can use the properties of equality to solve an absolute value, which means whatever you do to one side, you have to do to the other. So let's do some solving. So the first thing that you should always do is get the absolute value by itself. That should always be your goal. So when I look at this first one here, the absolute value is not by itself, and in order to do that, I look that there's being subtracted 2 from it, so I'm going to do the opposite and add 2. And remember, whatever you do to one side, you got to do to the other. So this gives me the absolute value of t equals 1. So once I've made it this far, this is where I stop and say, this means what numbers are 1 space away from 0 on the number line? And my answers are +1 and -1. Both of those, if I take the absolute value of them, I get 1. So same idea with the next one. The first thing you always need to do is get the absolute value by itself. Now there's no sign right here, so that means that 3 and this absolute value are multiplying. So to undo multiplication, I'm going to divide. So I get the absolute value of n is 5. So remember, you're thinking, what numbers are 5 spaces away from 0 on the number line? And your answers are +5 and -5. All right, this one's a little trickier, but pretend that your problem just looked like this. We'll even make it a W. What would you do first? Hopefully you're saying add 2 to both sides, and then you divide by 3. So just because there's an absolute value here doesn't mean that we're going to solve this any different. The first thing that we want to do to both sides is add 2. So we get 6 equals 3 times the absolute value of w. Remember, we're trying to get the absolute value alone so that we can evaluate it. And once it's alone like this, you ask yourself, what numbers are 2 spaces away from 0 on the number line? And that would be +2 and -2 for w. So, is there a solution for this? Explain. So if we were to solve this, we would divide both sides by 2, and we would get this. And then the question we would ask ourselves is, what numbers are -7.5 spaces away from 0? And because this is negative here, we can't have distance that's negative. So no solutions And the reason is distance cannot be negative. So let's solve some harder ones. These ones are a little strange because there's stuff hanging out inside the absolute value. Now remember, absolute values are like grouping symbols, so we can't do anything inside. So what you have to say is whatever is inside of here, whatever this stuff is 6 spaces away from 0. Now remember, there's two options here. All of this stuff inside could be at positive 6 on the number line, or all the stuff inside could be at negative 6 on the number line. So what we're going to do is we're going to create two different equations to solve. So the first one is c minus 2 could be at positive 6, or c minus 2 could be at negative 6. And now when we solve these two things, we're going to add 2 to both sides here. So we get that c could be 8. There's one of our answers. And if I do the same thing over here, I get c can be negative 4. Now remember, that means that when I plug these two things in, I'm going to get a distance of 6 spaces from the number line. So let's plug it in. So let's say 8 minus 2. Is that 6 spaces away from 0 on the number line? And it definitely is. Now if I plug in negative 4, I get negative 4 minus 2, and I want to know if that's 6 spaces away. So I get this, which we know is true. Do not solve this and put plus or minus 8 on the outside here. Solve two separate equations. So let's skip B and just do C. So same thing, I have whatever is inside of here has to be 14 spaces away from 0 on the number line. So this stuff has two options. This could equal positive 14, or it could equal negative 14. Now if we solve, I get that D could be positive 2. There's one answer. Or D could be negative 2. One last type of problem. I can give you 2 points here, 17 and 27, and ask you to go backwards. If these are my solutions, like 8 and negative 4, I want you to come up with the equation that would make them true. So you got 3 steps to do this. The first thing you're going to do is find the midpoint between your 2 points. So to do that, just start counting in. So 1 in, 1 in, another one in, another one in. Keep going in on both sides until you reach the middle, which is right here. 22 is our midpoint. Now the next thing you want to do is you want to find the distance between here. So here to here. So it's 1, 2, 3, 4, 5. So that means it should also be 5 on this side because it's right in the middle. And then our equation is the absolute value of x minus the midpoint, which was 22. And that equals the distance from the midpoint, which is 5. And you can check this because you can solve this. So absolute value of x minus 22 equals 5 means that x minus 22 could be at positive 5, or x minus 22 could be at negative 5. And if you add 22 here, you end up with 27, which was one of our solutions right here. And if you do the same thing here, you get 17. 17, which was our other solution here. So I didn't put this on the Can You Prove It page because I wanted to leave it here, but I want you to try this one on your own. In addition to these two very blurry, for some reason, Can You Prove It problems. Make sure you write down any questions you have, and we can go over them in class tomorrow. Enjoy your night.